Well, that was a disaster. Well, hello! Well, that was a disaster, wasn't it, guys? If you refresh my, the problem is some of you guys might miss this. Part 2, water crystallization part 2. I should be live now. There we go. Water crystallization part 2. Made a mess. I'll see if I can join those two videos together. I have no idea how I'll do that, but I'll figure something out. Right. Let's see whether or not this actually now works again. I've just done a quick reboot of my computer. Hey, Laura, thanks for making it back. I'm really worried that everyone's going to be like, I don't know where he's gone. Oh, that's really funny. Well, that was a bit of a mess, wasn't it? I don't know what's going on here. I haven't even checked my pen yet. This is where I do this, and there we go. It's back again. Isn't that strange? It all of a sudden just needed a bit of a restart. Go figure. 47 over 16 is 2. This is where it just doesn't do it. 2.94. Divide them all by the smallest gives me 1. 2.96, and I get 2 divided by 1.96, and I get exactly 1.50 when I do that. Hey, Caitlin, thanks for coming back, guys. Backstreet's back, all right. I like it. Backstreet's back, all right. Are you guys staring at my ceiling? Oh, I didn't share my screen. Ugh. This is not going very well. Oh. No, he's a forehead. Yeah, Mr. Duncan, we can only see your forehead. I'm sorry, guys. That was just a computer glitch. Yeah, multiply by 2, and I get AL203. Yeah, bit of a computer glitch there. Back to it. Right, guys, this is now getting a lot harder because more elements are now appearing. So we're going to do carbon. I'm going to make my pen a bit thicker for this one, if it lets me. So carbon, hydrogen. Sodium's over there. And carbon, hydrogen, sodium, and oxygen. Right. Do you know what? I'm suddenly thinking, don't even need to do it. I'm just going to do it this way. They're already listed for me. Can everyone, by the way, is it all working now? Is everyone seeing my screen now? Because all I just have is 5 head. Right, turn the percent to mass. Sorry. Oh, it's already done. Winner. Divide them by their ARs. This isn't actually as hard as it seems. Over 23 for sodium. Over 1 for hydrogen. Carbon, oxygen, 16. Run the maths. I like it. 0.219 divided by 23. I get shift-eng. I get 0.00952. Oh, 0.0095. Oh, it's the same number. Hope you guys have picked up that all right. Have you guys all figured out the shift-eng button? It's the best button ever. Shift-eng. You've got to do it twice. I'll show you how to do that in a bit. 95. It's the same number. 0.457 divided by 16. Oh, that's not. Uh-oh. Oh, my pet. 0.0286. Right, divide them all by the smallest. Well, that's easy. 0.0095. I'm just going to, yeah, same. The only one I actually need to do is that one. Yeah, because we know that's going to be 1, 1, 1. And what's that guy? Divided by 0.0095. And I get 3 dead. Yay. So, final answer is sodium 1, hydrogen 1, carbon 1, sodium hydrogen carbonate. Woo! Yeah. I like it. Next. Right, percent to mass. Hydrogen, 3.1 grams. Phosphorus, 31.6 grams. Oxygen, 65.3 grams. Right, over 1, over 31, over 16. Can someone check my phosphorus, please? The soda of baking. Lynn, you're absolutely right. It is the soda of the baking variety. You're absolutely right. Right, so, well, that one's just going to be 3.1, isn't it? 31.6 divided by 31. Hang on. 31.6 divided by 31 gives me, 31.6 divided by 31 should give me 1. 1.02. Yeah, I've got to give it, it's correct. Next, oxygen, 65.3 divided by 16 gives me 4.08. Excellent. Divide them all by the smallest. Don't forget to divide them all by the smallest. Yeah, 1.02. 1.02. 1.02. Right, so obviously 3, 1, and 4. Yeah. I know that seems a bit pointless, but it's just, you've just got to do it, folks. Yeah, it is important that. So that's going to be H3PO4. Oh, it's phosphoric acid. You need that one for GCSE. You don't need its formula, just its name. Phosphoric acid. Isn't that nice? Next, I think this is the last one now, folks. No, I tell a lie. Tell a lie. Next, already done grams for me. Over 23, over 12, over 16. They've already done the grams bit, which is ace. Guys, what's the answer to C? C was Al2O3. There we go. Because you had to double it at the end because you had a fraction. That's why, Lara. Oh, sorry, that's Mel. Yeah, that's why. Next, 0.167 divided by 23 gives me, oh, shift eng, 0.00726. Next, 0.0435 divided by 12. Shift eng, 0.00363. Next, 0.174 divided by 16. Don't need the eng button. 0.0109. Divide them all by the smallest, which is that one. Yeah, I always tend to do it that way, just like dividing the first one by itself, so then I know just to overlap it onto all the rest of them. Yeah, 0.00363. Right, that's going to spit me out 1. That's nice. 0.00726 divided by 0.00362. The answer is 2. 2.00, actually 2.01 technically. Yeah. Next, 0.0. My naught button on this calculator is really dodgy. 0.00363. And I get 3. Dead on. Absolutely dead on. Right. Formula is Na2CO3. It's sodium carbonate. Yay! Cool. I like it. Okay. Reacts with oxygen to form an oxide. What is the empirical formula of copper oxide? Okay. So it says, let's just zoom in on the question bit. 0. of copper reacts with oxygen, question mark, to form that much copper oxide. Right. So we've got copper at 0.15 grams, but then the oxygen is a question mark. They've not actually told us the mass. What they've told us is the mass of copper oxide. And the mass of copper oxide was 0.188. Right, guys, we need to minus away the copper. Minus 0.15. And that will give me the mass of oxygen. 0.188 minus 0.15. And I get an answer of, so this is my mass of oxygen. 0.038 grams. Because mass is conserved. Right. Run the steps. Percent to mass, mass to moles. 63.5 on your periodic table over 16. 0.15 divided by 63.5 gives me shift eng, 0.00236. 0.038 divided by 16 gives me shift eng, gives me 0.00235. Divide them all by the smallest. You can see where this is going. Yeah, you can see where this is going. 1 and 1. The empirical formula of copper oxide is CuO. I like it. That's copper, by the way. So that actually is going to be copper 2 Roman numeral, copper 2 oxide. There you go. Next. Okay. 1 gram of phosphorus reacts with fluorine to form phosphorus fluoride. Right, so P is reacting with F, and we've got 1 gram of that guy, but we don't know how much of that guy is. We're going to make P, F, and there are going to be question marks over the number everywhere, but it doesn't matter because we're going to make 284 grams of it. Right, so minus 1 gram. Just minus 1 gram of phosphorus is going to give me 1.84 grams of fluorine. Right, over phosphorus, 31, over fluorine of 19, I believe. 1 divided by 31 gives me 0.0322. It's actually 323 technically. Next, 1.84 divided by 19, and I get 0.0968. Divide them all by the smallest. 1, 0.0322, and I get, I'm assuming, 3, 0.0968 divided by 0.0322. And I get 3. Final answer is PF3. Right, guys, that brings us to the end of it. That brings us to the end. So I'm going to say ignore this whole red box. Ignore that for your mark. So on our data sheet, which I'll do in a minute as well, we're going to have 2 for this one, 1 for him, 1 for him being correct. Number two is going to be 1 for him because it's not ionic and doesn't form molecules. If you put it because it's ionic, you'll get the mark. Yeah, and then 1, 1, 1, 1, 1, 1. Too many questions. 1, 1. Last 2 are hard, folks. Last 2 are up another level. So total marks 1, 2, 3, 4, 5, 6, 6 to 11. So it's out of 11. It's out of 11. Yep, there you go. So you can just add that to the sheet that I created. See if I can make my sheet appear. I bet I can't. I remember this thing could do something really kind of, hang on. I've done something like this before where I made a mistake and then I managed to reopen all my tabs. Not that it matters. Actually, you know what? I'm going to find it anyway. I know that I think my lesson's actually running out. I've only got like 15 minutes. It's all I need for water crystallization. We'll do that in a minute. Right. Okay, guys. Water of crystallization. I'll do it at the bottom. Whoosh. Okay. Right, guys. Title. I'll make my pen a bit fatter. Water of crystallization. I'd spell with an S and let's just spell it with a Z, which is American. Water of crystallization. So you guys will have come across this. I will have mentioned this in my lessons previously. I'm just checking that this thing's all still working. Yeah. And that is, you guys have seen this. And you guys have already learned this. I've already taught it to you. 5 H2Os. Now that dot there means trapped inside or bound to, trapped within. Excuse me. Oh, came out of nowhere. Trapped within. So what this is here, this is a blue, you guys recognize this because this is a really pretty blue crystal. Yeah, these are copper sulfate crystals. Now, copper sulfates, when they have the water in it, it's blue. But when it has no water, this is called a hydrated salt. It just means that there's water trapped inside it. If you have non-hydrated, if you just have copper sulfate, then it's white. This is said to be anhydrous, and you'll recognize that. Anhydrous copper sulfate. Year 10, what is it? Oh, thanks, Caitlin. Saying bless you. You're such a sweetie. Guys, what's this the test for? Anhydrous copper sulfate. What is it the test for? This has a use. Test 4. First person on the chat. Laura's a winner. Well done, Laura. Well, second, Caitlin. Third's and Dominic. Dominic's coming third. Caitlin second. Laura's first. Who's going to come in fourth? Fourth. Who's going to come in fourth? Come on, guys. You guys are like, but the answer's already been written. It's the test for water. Yep. Sophia. Yeah. Test for water. Yeah, it's the test for water. Because you add that to it and it turns blue. Winner. So, okay. Well, the big question is 5 H2Os. Yeah. So it turns out that different salts trap different amounts of water. And we can actually work this out. Now, there's a reason why I teach this directly after empirical. Mr. Duncan, when do you use oxide or peroxide? Oh, Mel. Okay. The only peroxide you need is that one. Because is water dihydrogen? Yeah, it's dihydrogen oxide. To get a peroxide, you need to have the same number of oxygens as the person who's bound to it. Oh, is that true? Peroxide. I'm trying to think of other peroxides. That they do exist, but you don't need to ever know them. I don't even know them, Mel. Yeah, the only peroxide you need is that one, hydrogen peroxide. There will be others. I'm gonna have to Google that now. Oh, the chemistry is gonna bug me. Okay, so we can now work this out. We can work out the amount of water, and it's really simple. So all you do is a practical. So you can put practical. So what you do is you will take. I'm gonna do an example. I do actually have some questions lined up, but I'm gonna ruin this now. I'm gonna do a really good example of another blue one, right? There's a dark blue substance called cobalt chloride. Oh, yes, COCl2, and this is anhydrous. Anhydrous cobalt 2 chloride. Oh, cobalt 2. Or is cobalt 3? No, cobalt's 2. Cobalt's 2. Iron 3, chromium 3, aluminum. Yeah, it's 2. It's definitely a 2. Is there a nitrogen peroxide? A nitrogen peroxide? No, there isn't. There's N2O4. There's an N2O4, but no N2O2. There isn't. Let me get back to you on that one. Barium peroxide. You're absolutely right. That is another peroxide. Ooh, barium peroxide. BaO2. It's because the barium's in a funny oxidation state. The oxygens is peroxide. No, the peroxide. The words peroxide means that the oxygen is in a funny oxidation state. Oh no! Stop it! Stop it! No, you're gonna ruin me. I've not finished. I've only got 7 minutes left. This is the anhydrous. Well, there is also a hydrated version. Yeah, there's a hydrated version, which is hydrated cobalt chloride. Now, what you'll notice in this diagram is that I've put the number of water molecules in as X. Yeah? Now, that X means there is an unknown. I think it's picking up my hand, and it shouldn't be. An unknown number of water molecules. So it's really easy to work it out. All you do is you take the hydrated salt. Cobalt chloride, and you're going to weigh out 10 grams of it. Now, by the way, that's actually too much. You wouldn't do 10 grams. You'd do 1 gram. You'd do 1 gram of hydrated cobalt chloride. And then what you're going to do, oh, is my laptop misbehaving again? No, it's not. It's my hand. I think it's because maybe my screen's damp. It's possible. We're now going to heat it. Heat until constant mass. Right. And it's going to change color. It's going to change to blue. So, guys, why has the heat got rid of the water? What has happened to the water inside the crystal? See who's still paying attention. I know it's right at the end of the day. I've lost everybody. Oh no. The water evaporates. Yes, thanks, Hao Ping. Thank you. So the water evaporates. Now, what I'm going to tell you is that I have 7.3 grams left over. Is that the right idea? Let's do 6.3. No. 0.63 grams at the end. I don't know what that means, like E-boy. I don't know what that means. But what we can now figure out is that the cobalt chloride here was 0.63 grams. And the water is the difference. It's the rest. It's whatever's left. It's whatever vanished. So the first thing I'm going to do is, for me to do empirical formulae, I'm going to go COCl2 line H2O. I'm going to do an empirical formulae trick. Number 1, percent to mass. I had 0.63 grams of cobalt chloride after the water left. The water, I had 1 gram minus 0.63. So I had 0.37 grams of H2O in the compound. Now I need to count particles. Get to moles. Divide them by 18 for water. Everyone in this room knows 18 is the MR of water. But what does cobalt chloride weigh? I have no idea. I don't even know what the number is for cobalt. Let me see if I can find cobalt. Cobalt, 59. Okay. Can. So I've got 59 plus 35.5 times 2. 59 plus 35.5 times 2 gives me 130. Right, so I have 0.63 divided by 130, and I go shift N, and I get 0.0000485. Now I do 0.37 divided by 18, and I get 0.0206. Divide them all by the smallest. One. How many water molecules did I have? 0.0206 divided by 0.00485. And I get 4.25. Right. It's a fraction. By the way, in water crystallization, you'll never actually get fractions. But if you did, that there is a quarter. Multiply everybody by the denominator. Technically, according to my maths there, the cobalt chloride times everything by 4 would be 4 dot, what's 4 point, times by 4. 4.25 times 4, and I get 17. That would technically be the right answer, even though you'll never have to do that. You'll never have to do that trick with questions at GCSE or A-level for that matter. Or at least I don't think so. A-level's a bit more tricky. They might do it. I think they have done it in the past, actually. Right. Guys, that's the end of empirical formulae. Now, I'm very aware that I don't want to overrun my lesson. Just take... There we go. Way! I'm so sorry. If I'd had like 5 more minutes, I would have been able to have done a few more examples and it would have made loads more sense. I don't want you guys to worry about it. I'm going to post on the classroom the worksheet. Have a go at them. See how you get on. Yeah, have a go. And I'll see you guys next lesson. I'll see you tomorrow. I'll post them on the classroom right now. I don't think there's many of them actually on this particular worksheet. Do you want to see me actually post it? Nah, I'll post it straight away though. Right, we don't mind. Do more examples. I concur. Okay, all right. Oh, I love you guys. You guys are awesome. Suckers for chemistry. Okay, more examples. I actually prepared for this. Right. Okay. Mr. Duncan, don't leave. Oh. Okay. So question number 1. This is where it would have been easier if I'd given myself a bit of a gap between each of these. I can actually. I can do this. Snip. Just gonna do more examples. Right. Can I just draw on this? Oh. Can. Okay. I'll show you this one. You're now looking at my ceiling again, aren't you? No, it's okay. It's okay. There we go. Okay, so, oh, come on. Where are we? There. A sample, this is where it won't let me zoom in anymore. A sample of calcium sulphate has an unknown number of waters and has a relative formula mass of 172. What is the value of X? Right, so guys, what this question has just said is that the calcium sulphate, they've given us the MR with XH2O, and they've told us this entire thing weighs 172. Well, what we can now do is take away the atoms that we know, minus the calcium. Calcium weighs 40, minus 40. This is where I ought to do it in bit by bit. Yeah, I'll do it. I'll do 70 minus 4, minus 40. Then sulfur is 32, so minus 32. Then minus 16 times 4. Yeah, 60. I don't keep. I keep wanting to write minus. Yeah, 16 is oxygen, but there's 4 of them. So 16 times 4 is 64. So minus 64. Right, what do I now have left? 172 minus 40 minus 32 minus 64. And I have a total left of 36. That 36 must have been water. Well, how much does each water weigh? 18. Divide that by 18, and I get 2. Yeah, so the value of X there, and that's just from using a total mass number that I was given. That was done on a GCSE, I think 2 years ago now. I actually went through a paper recently with my year 11s and it made an appearance, and I'm pretty sure it was that one. Next. Right. Oh, I like this one. This one's not very nice. I'm going to make it easier. Hang on a minute. Let's go for one of these. This is the one I want. No. I want question number 4. That's what I want. I'll take that. Okay. Question number 4. 11 grams of hydrated. So I've got 11.25 grams of hydrated copper sulfate, .XH2O. They heated it until it loses all the water. Its new mass is right. So I've heated that, and I have produced a new solid, which is only copper sulfate, and that weighs 7.19 grams. So what was the mass of water that disappeared in the cloud? See what I've done there? So this was it bound in the crystal. This is it bound dry. Yeah, and the gases escaped as a cloud. There you go, as steam. What mass of water was it? I'm doing it on my calculator now. Loads of people spit me out the answer now. The answer is I've lost 4.06 grams of water. What? Go away. 4.06 grams of water. Right, now that I've worked out the water, now I can run my empirical formulae. Copper sulphate, line, H2O. Right, I had 7.19 grams of copper sulphate. On its own, no water. I had 4.06 grams of water. Right, divide that one by 18. 4.06 divided by 18 gives me 0.226. Next, what does copper sulphate weigh? 63.5 plus 32 plus 16 times 4. 63.5 plus 32 plus 16 times 4 gives me 159. I'm going to divide that by 159.5. So 7.19 divided by 159.5. And I get 0.0451. Divide them all by the smallest, folks. If I divide that by the smallest one, that one, of course, is going to end up as 1. And this one divided by the smallest, 451, 0.226 divided by answer gives me 5. So that there equals 5. So X is equal to 5. I can now replace that one there, the 5. Right. Would anyone like me to do any more, or are you feeling a bit more confident with it, or do you want another one? I don't know how many people are left. I'm gonna have to take these videos off YouTube, combine them together somehow, and then post them back on. It's a bit of a nightmare. Does anybody want me to do any others before I leave? I don't want to like keep you guys if you don't want me to keep you. Like, I get it. Sure. Will it only be water bound to the crystal? Yes, it is, Libby. There have been decomposition questions where they've used this method. Do more because it's fun. Attia, you're such a sucker for punishment. What? Is this fun? I'll give you one more. I'll give you one more, folks. I'll give you one more. You guys are so funny. Okay, one more. I'm going to make it as hard as I can. I'm going to go for my hardest one. Where's my most difficult one? Actually, the great thing is about these questions is they're not really that difficult. Okay, let's do this one. Let's do this crazy long one. By the way, I'm looking at it going, I don't really know why it's so long, because there isn't really an awful lot to these. Right, okay. Can I move that down a little bit? No, pretty much. Okay, so 13.2 grams of zinc sulphate. Zinc sulphate.x was heated strongly. I have got zinc sulphate, oops, lost the S, .xH2O, and I have got 13.2 grams of it, was strongly heated until no further change. On heating, all the water crystallization evaporated. Calculate the number of moles of water in the crystal, given that the zinc sulphate, that 7.4, right, zinc sulphate left was 7.4 grams. So first question, how much cloud did I make of water? I think you guys have won this now. Were there any learning objectives? Nah, not really. I've forgotten them, Lara, don't worry about it. Be able to do water crystallization and understand that if you get fractions in empirical, you need to multiply everybody. They were my 2 learning objectives. 13.2 minus 7.4. 5.8 grams of water. Right, on to my next process. Zinc sulphate. Zinc sulphate, line H2O. It's the same as empirical. Percent to mass, mass to moles. 5.8 grams. Right, over 18, we always know the MR of water. At A level, 18.0. Yeah, just nice to throw that in there. Zinc sulfate. I have no idea what zinc is. I haven't got a clue. What's zinc? 65. Okay. I've lost it now. 65 plus sulfur 32 plus 16 times 4. 161. 7.4 over 161 gives me 0.0460. And then 5.8 divided by 18 gives me 0.322. Divide everybody by the smallest. Do you realize now why there is an order to teach calculations? It's way better to teach empirical after doing, water crystallizations after doing empirical, because the process is the same. 0.322 divided by 0.0460, and I get 7 exactly. Look at that. X is 7. Zinc sulfate 7H2O. There we go. Woof, woof, woof. Yeah. All over it. All over it. Right. Hey, guys. Okay. Right, guys. I'm going to leave you to your evening. It has been awesome to see you guys, as always. I will post the empirical formulae worksheet on the classroom right now, and I'll see you guys tomorrow. Catch you later, guys.